Hello. In lesson 4.4, we will be able to determine if an equation represents a linear proportional relationship by using various methods. Let's begin by knowing how we can use what we know about the constant of proportionality to write an equation. As we said in the previous lesson, the constant of proportionality is represented by the variable k. We find this rate by dividing our y-coordinate by our x-coordinate. Let's break this down. First, let's isolate the y. To isolate this y, we would multiply both sides by x to give us the following equation: y equals kx. Let's continue by looking at the various names for each of these variables. Our k, as we called earlier our constant of proportionality, can also be called a rate of change, or it can be called a unit rate when y is proportional to x. Our y-coordinate can also be known as the dependent variable because it depends upon what x, our independent variable, is that will change that y when applying the rate of change. I used to use a phrase saying, "Y be dependent, expect independence." So y be dependent, expect independence. To help me remember which is the dependent versus the independent variable. So let's apply this to particular equations. When we want to find the unit rate, we are looking for k. So let's rewrite the basic equation again. Y equals kx. We know that k, the constant of proportionality, is also known as your unit rate. So let's compare our basic equation with each of the ones represented below. Our unit rate in the first one would then be 8. Our unit rate in the second equation would be negative 0.45. What would our unit rate be for the last equation? If you thought the number 1, that is correct, because as we know, in front of every variable standing alone is that invisible number 1. Let's determine which equations are proportional. In number 1, if we use our example, y equals kx, does it match with the equation written in number 1? Is it written in the same format? Yes, it is. Because it's written in that same format, we know that our equations are proportional. Our constant of proportionality, or our K, is 1/4. Let's rewrite the basic equation again. Y is equal to Kx. For number 2, this is not a proportional equation. The -4 does not make it a proportional equation. It is not written in the same format, y equals Kx. How do you think you can write an equation from a table? Here's a hint. Think about the correct form for a proportional equation. So if we know that y equals Kx, we simply need our unit rate, or our constant of proportionality, to be able to write an equation from a table. Therefore, let's find our K. If we divide y by x, we would have 8/1. 16 divided by 2 gives us 8. 32 divided by 4 gives us 8. 48 divided by 6 gives us 8. And 64 divided by 8 equals 8. Therefore, our K is equal to 8. Our equation now can be written as y equals 8x. Let's write an equation for this table. Again, our format is y equals Kx. When I divide, we both have it starting at the origin, which makes it very important in determining the y equals Kx. 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. And 12 divided by 4 is 3. Therefore, K is equal to 3, and our equation is therefore y equals 3x.